Hi. Now let's talk about cleansing agents. So basically we have two types of cleansing agent. One is soaps, okay, and the other one is detergent. As we know, soaps are biodegradable, and detergents, they will actually, the product they will derive from petroleum. So basically this is not so environmental friendly. Now how do we now basically what are soaps? Now number one, they are actually the sodium or the potassium salt of long chain of fatty acids. Now when we say long chain of fatty acids, so this is the fatty acids, okay, these are the fatty acids with 12 to 18 carbon atoms. Now why we need such a long fatty acids? So we are going to review it again later on, okay. It has to do with the ability to dissolve in lipid, so that the lipid can be lifted away from the surface and do the cleansing, okay, job. Now, so why must it be sodium or potassium? Because so whatever salt of potassium or sodium must be soluble in water. So that's why we have sodium and potassium salt. All right. Now, so how do I prove that it is a salt? Now we call this now RCOOH. So this is a general formula of carboxylic acid. So when the carboxylic acid reacts with NaOH, which is an alkali, so we get a salt. All right, a salt and a molecule of water. So this process is known as neutralization. So if you look at it carefully, the general formula of soaps, okay, are RCOO minus Na plus or RCOO minus K plus. So this is a sodium salt of long chain fatty acids. This is a potassium salt of long chain fatty acids. Now, so of course we are not going to produce the soaps, okay, using neutralization reaction. We are going to do it in a process known as saponification. So in neutralization, we use acid and alkali, right? Alkali to produce soaps and water. But in saponification, basically we use fat or we use oil. All right. Now because oil provides the suitable fatty acids, okay, with 12C to 18C, which are suitable to make soap molecules. So in saponification, basically the alkali that we use is concentrated NaOH or concentrated KOH. So when the sodium hydroxide or the potassium hydroxide react with fat, then we have the soap molecules and the glycerol. Now, so let me show you, okay, the process of saponification. So basically this is a molecule of fat. All right. Now, so we have the glycerol. Now this is the glycerol. The molecule is glycerol. All right, and these are the three fatty acids. So when one molecule of glycerol reacts with three molecules of fatty acids, then we get a molecule of glycerol. This is triglyceride. So we are going to use alkali to break down the fat. Okay, now let's see the process of saponification. So we have a molecule of fat or triglyceride here. Now, so right now we use alkali to break down the fat molecule. So when it breaks down, basically this bond, okay, this bond is broken, and then the H here is added to the glycerol. All right, forming a molecule of glycerol. And then what about the NaO here? The NaO here will join with the fatty acid chain, forming a salt. So as you can see here, one molecule of fat will be broken down by NaOH to form a molecule of glycerol and three molecules of salts, a salt of long chain fatty acid. Now, so if you look at the structure of the long chain fatty acid, now so basically this is the cation Na plus here, and this head is actually, it carries a negative charge, and what is bonded to this C is a long chain fatty acids with 17 carbon atoms. Now, so every corner here represents one carbon atom. So look at it, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we have 17. Oh, I guess that's not right. We should have altogether 18 carbon atoms, right? Because if you look at it, so we have 17 carbon atoms and 1 carbon atom here. So by right, okay, there should be another C here. So this is first C. So we have 2, 4, 6, 8, 10, 12, 14, 16, and this is 17. So 17 C and COO minus and A plus. Now, so why the fatty acid chain here has to be long? Now, because we know for a fact that this part is hydrophobic. That means to say that it likes lipid. It will be able to dissolve in lipid. While the head here, the COO minus, okay, is hydrophilic. It is able to dissolve in water. While this part Na plus is not involved in the cleansing action. Yeah, basically it will be just washed away with the water. Let's look at it, how we do the cleaning action. Now, so recall the soap. Okay, the soap has a positive, okay, or the cation, okay, part known as the Na plus or the K plus, and then this is a COO minus head, and this, okay, this would be the long chain fatty acids. Now, so during the cleansing action, so the hydrophobic tail dissolve in lipid, while the head here, which is hydrophilic, will be exposed to water. So upon agitation means water is moving. Okay, when water is moving, so what happens is the soap molecules here will be able to lift up, okay, the lipid from the cloth surface, and then as a result, when the lipid is fully lifted, so the anions here, the anions head or the hydrophilic heads here actually surround the lipid molecule, preventing the lipid molecules or the lipid globules from combining together. So in this case, the lipid globules are floating, or the tiny droplets of lipids are floating in the water, forming an emulsion. All right. So what is emulsion? Basically, emulsion is just lipid globules or lipid droplets floating in water. So since there are negative charge on the surface of the lipid, they won't combine together, or they won't actually bind together to the cloth again. So when we throw away the water, basically the lipids are thrown away as well. Alright, now there will be an aspect, okay, if you want. Now make sure that you understand the cleansing agent. Okay, there will be an essay here perhaps. Now let's look at the preparation of soap. Now how do we do it? Now, as mentioned here, we need fat or oil, we need concentrated NaOH or KOH, we need heat source. Now, so this is a beaker. Okay, I have just poured in 50 ml of concentrated NaOH, and then I pour in 10 ml of vegetable oil. Of course, the vegetable oil will be floating on the surface of NaOH. Then this is a glass rod. Now I'm going to heat up the mixture. Okay, I throughout the process I stir them up. Then, of course, the vegetable oil will dissolve in concentrated NaOH. Why? Because this is an alkaline hydrolysis. The vegetable oil will be broken down by NaOH to form salts. Okay, and what? Now let's recall. When it is broken down, we form salt molecules and glycerol as a byproduct. Alright, so glycerol is an alcohol. It is still soluble in water. Alright. Now, so that means to say that again, right now I have what? Now, when vegetable oil fully dissolved in concentrated NaOH, so I have concentrated NaOH. Okay, of course, because they are in excess, I have glycerol and I have the soap molecules. Then I'm going to cool the mixture down. After that, I'm going to dissolve NaCl. Okay, this is table salt in water, and I pour the water in and I stir. Okay, stir the mixture while heating. So what happens is this. So the salt, okay, the salt NaCl is added to reduce the solubility of soap in aqueous solution. So this will cause the soap to be precipitated out. So as a result, we will be able to see a lot of white solids, okay, forming a lot of white solids precipitated out on the top of the mixture. So what do we do next is to filter the soap out from the solution. Okay, so this will become the filtrate. The filtrate will be thrown away, and this will be it will be dry, okay, in between two pieces of filter paper. So if you rub it with your finger, you will discover that it's slippery and is foaming. That means to say that it forms foam, okay, bubbles. So basically this is all about soap. So of course, okay, if you ask me whether the equation is important, I would say yes. Okay, at least you need to know, okay, what are the reactants here, and then what are the products. Okay, this is the byproduct and this will be the product. And then there are two parts. Okay, there are two parts in the soap molecules that enable it to become a good cleansing agent. One is a hydrophobic tail, the other one is a hydrophilic head. And A plus here, or the K plus here, is not involved in the cleansing action at all. Alright, so any questions you can still okay post in WhatsApp.